You ever looked at those giant power lines stretching across fields and wondered, why is electricity sent through them at such high voltage? Why can't we just send power the same way it's used in our homes, at 220 volts? Today, we'll uncover the science behind high voltage transmission, why it's essential, and how it saves billions of watts of energy every day. Electricity starts its journey at a power station where generators produce it at a few thousand volts. But homes and factories are often hundreds of kilometers away. When electricity travels that far, the wires resist the flow, and that resistance causes power loss as heat. The power lost in the wires depends on current, I, not voltage. Mathematically, power loss equals I squared times R. This means if we reduce the current, the losses drop dramatically. So, to send the same amount of power with less current, we increase the voltage. Let's say we want to transmit 1 megawatt of power. If we use 1,000 volts, the current will be 1,000 amps. But if we raise the voltage to 100,000 volts, 100 kV, the current drops to just 10 amps. Lower current means less heating of wires, smaller energy losses, thinner and cheaper conductors. So, high voltage is the smart way to make long-distance transmission efficient and affordable. But how do we increase or decrease voltage safely? That's where transformers come in. At the power station, step-up transformers raise the voltage from thousands to hundreds of thousands of volts. Electricity reaches a city or village. Step-down transformers reduce it to safer levels, 11 kilovolts for distribution lines, and finally, 220 volts for your home. Transformers are the real heroes behind the scenes, allowing high-voltage transmission to work without losing energy. Here are the main advantages of using high voltage. 1. Reduced power loss. Less current means minimal I squared R loss in conductors. 2. Smaller conductor size. With lower current, thinner wires can carry the same power, cutting costs. 3. Higher efficiency. Power plants can transmit electricity over hundreds of kilometers efficiently. 4. Better voltage regulation. The voltage drop along transmission lines becomes smaller. 5. Lower cost of transmission. Fewer towers, smaller conductors, and less power loss. All reduce total system cost. Today, technology has taken this even further with HVDC, high voltage direct current systems, transmitting electricity at over 800 kilovolts across continents with minimal losses. From the hydro dams of China to the deserts of Pakistan, high voltage transmission keeps modern life running quietly and efficiently.